So before subnetting, we started discussing actually IP routing. IP routing is a process of moving IP traffic from one network to another network, and it involves two activities: finding the shortest path and forwarding traffic to shortest path, right? And routing conditions also, and routing types: static routing, dynamic routing, and default routing. We successfully completed static routing. Static routes are configured, maintained, and updated by network administrator manually. An administrator should know destination network, and AD value is 1. Akhil explained about how routing tables are updating and how to configure static routing and all, right? So today we'll continue with the same. So in this topology, if we configure static routing, how to configure static routing? This is A network, A LAN 192.168.1.0/24. Means what? It's a default mask. It is not customized. And router H LAN network is 10.0.0.0/8. Is also default network. Now scenario is A to H scenario. How to reach A to H? If you use static routing, method. So what is the first thing? From A to H, how many paths are available? 3 paths. Traffic should exit via 0/0, 0/1, 0/. Out of 3 paths, which is the best path? So that best path selected by network administrator manually. Like we have to decide the path action. It could be 0/0, it can be 0/1, it can be 0/2. Like how we are defining? Like if you use IP route, destination network 10.0.0.0, 255.0.0.0, and exit point, exit interface. If we configure 0/2, then 0/2 is the best path. So traffic will go via 0/2 and reply will come back in the same path. Or if we configure 0/1, then traffic will go via 0/1 and reply will come back in same path. So which is the best path? It depends upon our action. Like network administrator has to be decide that best path. Let's say configure 0/0. So path selection. Path selection by admin. We need to path select action. So next point is, after some time, what if best path is failed? If 0/0 is down, you configure to reach 10.network 0/0. Now it is failed. Now users can communicate. So router A LAN users, H LAN users, will they communicate?
No.
No communication until we need to reconfigure 0/1. So now we need to configure 0/1. Right? Now they can start doing communication action. Again, your best path is up. 0/0 is up. And how traffic will reach 0/0? Again, need to reconfigure 0/0. So this is the path. This is the point here. If any new network is added, this network manually we need to update in routing table. So everything is manually need to be updated. No automatic updates. And we should know destination networks. Should know destination DST networks. All networks we should know. router B networks, router C networks, router E networks, and between C to E, between B to E, WAN link, all destination networks we should know, right? And routing tables we need to update manually. All routing tables manually need to be updated. So this is how exactly if best path is failed, seconding best path manually. So this is how exactly static routing works. Now let me explain about dynamic routing. In same topology, if we configure dynamic routing, this is of static routing, if we configure dynamic routing, now how many paths are available from source to destination from A to H? The same 3 paths. Now dynamic routing protocol will find the best path automatically. Protocol will find the best path. In static routing, path selection by admin. In dynamic routing, path selection by automatic.
It's automatic.
Automatically path selection. Let's say, as per dynamic routing, 0/0 is the best path. Now traffic will go via 0/0, reply will come back in same path. Like what if after some time 0/0 is failed? What happen in static routing if best path fails?
No communication between host and
No communication from A to H. But in case of dynamic routing, if best path is failed, then within a seconds, so within a seconds, dynamic routing protocol will find the second best path and traffic is being forwarded. Communication still it is enabled actually. Router A and H LAN users, they can communicate even one link is down also, because there are 3 links are available. If one link is down, within a seconds your traffic is being forwarded to a second best path. It will find automatically. If second best path is also failed in some cases, again within a seconds traffic will go via 0/2 automatically. After some time your 0/1, sorry 0/0, which is the first path is up, then automatically traffic will redirect to 0/0. So everything is automatically happen. We just need to be implement dynamic routing protocol. The protocol will manage everything actually. As the network engineers, we need to monitor the traffic, how the traffic is moving. That's all. Protocol will manage everything. If any new network is added to the existing topology, a router K is added. Network is 9 dot network. That's all. 9 dot network. It will come to B router, A routing table, C routing table, E routing table, H routing table, all routing tables. Because entire dynamic routing protocols works like a neighbor to neighbor updates, neighbor formation. Neighbor means directly connected device called neighbor. Example for B, which routers are neighbor routers?
A and H.
So whenever there is update in B, because 9 dot network K router is added to B, you know what B will do? Oh, there is one new update for me. I need to update to my neighbors also. So B will update to A and H. Then for A, which routers are neighbor routers?
C and D.
Then automatically within a seconds, A will update to C and D. So C will update to neighbor, D will update to neighbor, H will update to neighbor, like neighbor to neighbor update. Then finally, all routers will maintain up-to-date routing information. 9 dot network information will be available in all routers. Correct?
Yes.
Yeah. The thing is, in static routing, we should know destination networks because we need to update routing table. We should know B networks, we should know C networks, we should know B to E networks, all networks, right? In dynamic routing protocol, no need to know destination networks. Anyhow, networks are automatically updating in routing table, then why you should know it, right? Destination networks are not required. Only your directly connected networks is information is enough to configure all dynamic routing protocols. Destinations are not required. The routing table will update automatically. So this is a major to static routing and dynamic routing. So which routing is best?
Dynamic routing.
Static routing. If you ask me which routing is best, I'll say static routing only. You know why? Because point number one, in static routing, who will find the best path?
Admin.
Admin will file a secure path, correct? Because administrator is finding the path now, which was a 0/0 0/1 0/2, so he can find a secured path. But in dynamic, which is who is finding the best path?
System automatically.
Protocol is finding the best path, right? So compared to static and dynamic, static routes are secured because administrator is finding the best path. And one more thing is, in dynamic we have automatic updates, right? Let's say there is serial 0/0 link on B router, it is down. It is down. So there is one change happen in topology. Then what B will do? Or you can say this 9 dot network is added to B router. And what B will do?
To the neighbor
B should update to
routers.
neighbors, right? So B is updating to neighbor. Hello, A router, there is one new update. You maintain 9 dot network. So A router is maintain 9 dot network. And 9 will update to neighbors. 9 dot network. 9 dot network. And H also will update 9 dot network. 9 dot network. Every router maintains 9 dot network. Like what after some time this link go down? If link fails, then B will
Updates.
start sending update to neighbors. So before a given 9 dot network, it is no more. You also remove it. Then A will remove 9 dot network, update to neighbor. So all routers will remove 9 dot network. Again, your link is up. Then what B will do?
It will
Update
send
to neighbor.
communication to update. Yeah.
Update to neighbors, 9 dot network is up. You also maintain it. So means any small change also happen in the topology, all routers will start updating. Agree? There will be hundreds of routers in the topology in real networks. If any small changes happens, if link failure or link is up, any neighbor is down, any neighbor is up, like even any small change happen also, then all routers will start running functionalities, running update. To send this update, protocol will consume your bandwidth. It has to be sent continuously update, right? Every router, all routers. Your bandwidth is being consumed actually. In real time, we pay for bandwidth, we purchase for the bandwidth. That bandwidth is consumed by for updates. In case of static routing, in static routing, no automatic updates. It means no wastage of bandwidth. So whatever the bandwidth is available, that bandwidth effectively can use for data transmission purpose. Then faster. So static routes are faster, secured, reliable, no wastage of bandwidth. There are advantages actually. It's not like that which routing is best, static is best or dynamic is best. Thing is, you should know like where to use static routing, where to use dynamic routing. Static routing is best for the smaller networks. If network is small, then we can easily manage. Agree?
Yes.
Yes. Like small networks and fixed networks, static routing is best. So when network comes to medium and larger, then better you go for dynamic routing only actually, because automatic updates, destination is not required. Advantages and disadvantages of static routing. Advantages: secured, reliable, faster, no wastage of bandwidth. Disadvantages: no automatic updates. We should know destination network. Admin work is more, so it is used for only small networks. Dynamic routing. How dynamic routing works? Discover the neighbor, finding the best path, maintaining up-to-date routing information, choosing the best path in available paths. Whenever best path is down, finding a new path and forwarding data traffic through that path action. What are the advantages of dynamic routing? Automatic updates, changes in network topology are updated dynamically. Only directly connect networks information is required for configuration, means no need of destination networks. Less administrative work. Selecting best path to destination networks. Finding second best path also when if best path is no longer available. More scalable, used for medium and larger networks. So these all are major difference between static routing and dynamic routing. It's clear, everyone?
Yes, clear.
Okay.
So small network means like, is there any count for that or?
Small networks.
So small, like, is there any count for small networks, like how many routers or devices or anything like that?
It's not like that. There is no fixed count to fix a number.
Okay.
Like as much how you can manage. If you're able to manage, you can maintain. You can build the network action.
Okay. Okay.
Small network and better you can assume that fix the networks. It's the best for static routing. Fix the networks. Example: have a 5 branches all over India wide. That's all. In future, I am not going to add any more networks actually. Just 5 networks, 5 branches fixed. That's all. Then once implement static routing, they can start doing communication. And further, no need to be changed also. Correct?
Just
This is
even if we
corporate.
add one more branch, then we can just add that branch details as well.
That is what. If you add one more branch, you need to add in all routers now, all 5 branches.
Mhm.
That will make your machine complex. So that is what static routes are recommended for fixed networks. Networks are fixed. Means you have a 5 branches only. That's all. If it is a corporate networks, like service providers, they can expand our network with the multiple branches. Then it is not suitable action. Then dynamic routing, because any network is added and automatically network will be updates action. Okay. I'll say dynamic routing methods. Basically have two types of dynamic routing, IGP and EGP. Interior gateway protocols and exterior gateway protocols. Interior gateway routing protocol and exterior gateway routing protocol, two categories we have. In IGP and EGP again, different type of categories. In IGP, have three categories. Like we call DVP, distance vector protocol, LSP, link state protocol, and ADVP, advanced distance vector protocol. In EGP, only one category which we call path vector protocol. Path vector protocol. So distance vector protocols are two types. Distance vector protocols are RIP, IGRP. Link state protocol is also two types of link state protocol. OSPF, ISIS. Distance vector protocol is EIGRP. Advanced distance vector protocol is EIGRP. Path vector protocol is BGP protocol. IGRP protocol is no more. It is enhanced. It is outdated. IGRP protocol is enhanced. EIGRP. It is enhanced. So no IGRP protocol. ISIS is modified into OSPF protocol. No ISIS. In RIP protocol, there are two versions. RIP version 2, RIP version 1. Even RIP version 1 is also outdated. We don't use actually. We use RIP version 2, OSPF, EIGRP, BGP in real networks. In CCNA level, in syllabus, we have only OSPF protocol. Even for Cisco exams also, you'll get the most questions from OSPF protocol. In real time, we use mostly OSPF protocol only. Like EIGRP protocol, BGP protocol will be covered in CCNP level. But I'll give this introduction part of RIP protocol, EIGRP protocol. We'll go for advanced level of OSPF protocol. Almost for 2 days, we are going to discuss about OSPF protocol only. Like 14th and 15th, tomorrow and day after tomorrow, we'll continue with OSPF. Today, we'll try to finish RIP protocol. If you understand RIP protocol, then you can easily understand OSPF protocol actually. Got it? Once OSPF is done, then we'll try to compare of RIP, OSPF, EIGRP, three routing protocols. Yeah. 10.1.1.1/8. This IP address belongs to which class IP address?
Class A.
Class A. Ten dot 2.1.1.1. 10.2.1.1.1/16. This IPs belongs to which class?
Class A only.
10.3.1.1.1/24 belongs to which class IP address?
Class A.
10.4.1.2/29 which class IP address?
IP belongs to class A only, sir. Sub network.
I think it's past 29 that it's invalid.
Why it is invalid, man?
Oh, sorry. Okay, I understand.
Okay, see, this point is what is the difference between first IP address and remaining all IP addresses?
First having default gateway and another having sub networks. Customized gateway.
First IP is
First IP belongs to class A, but default gateway is there, and another IP having
default
customized.
gateway, no, default subnet mask.
Okay, default subnet mask and customized subnet mask.
Yeah. So first it is a default subnet mask and remaining are customized, right? It is subnetted. If IP is not customized, means it is not subnetted, then we can say this is class A or class B or class C. There is a class. We call it is class full network. So we can say class this is IPs belongs to class A or this IPs belongs to class B or class C. So those networks we call what? Class full networks, means which are not subnetted, which are not divided actually. Once IP address is subnetted, once IP address is customized, then how we can say is a class A or how we can say is a class B or class C or class D? No, no more classes. We call it is classless. Classless because subnetted now. It is customized. So two types: class full, classless. Class full means not subnetted. There is not support for subnetting. Classless is subnetted, support for subnetting. Similarly, in routing protocols also, some protocols are classful routing protocols and classless routing protocols. So classful routing protocols does not support for subnetting, whereas classless routing protocols support for subnetting. Like IGRP is outdated now because it's a classful routing protocol. RAP version 1, classful routing protocol. The rest of the protocols are classless. Classful routing protocol does not support subnetting. RAP version 1 and IGRP do not send the subnet mask in the update. Classless routing protocol carries the subnet mask in the update. Means supports the subnetting. Which protocols? RIP version 2, EHRP, OSPF, these all are classless. So classless routing protocols are best actually because supports for subnetting. Clear? Any doubts?
A little confused with how can you say a subnet is class or like classless? Like, so how can you say it's a default subnetting or customized subnetting based on the slash
Mask.
subnet?
Yeah.
Okay, so if it's 8, that means it's a default.
Default.
So how can we say
/8,
that?
/16, /24 is all
Okay.
the default.
Okay, then the second IP address that you wrote, it has /16, right? Why is that not a default? The second IP
But
address.
IP address is 10. From class A, I customize into 16.
Got it.
What is
Okay.
class B range? 128 to 191. For these numbers, if we use 16, then is
Oh, yes. Got it.
class full.
All right.
It's not
Okay.
customized actually. But
Okay.
what I done, I use class A
10.
IP and I make it as a 16. This is customized based on my requirement. I customized it actually.
Got
It's
it.
a classless.
All right. That makes sense. Thank you.
So there's a difference between classful and classless routing protocols. Let us continue with RIP protocol. RIP is routing information protocol. RIP is routing information protocol. It's a distance vector protocol. It's an open standard protocol. Open standard means whenever if I say open standard, it works in multiple vendors. So we can configure RIP in Cisco routers. We can configure RIP in non-Cisco routers also. It's not like a Cisco proprietary protocol. It's open standard protocol. It's a good thing. Advantage of RIP, open standard. And the scientist name, Bellman Ford, the same scientist name he used for the algorithm also. So uses Bellman Ford algorithm. It's a classless routing protocol. Support for subnetting in RIP have two versions, RIP version 1, version 2. Forget about version 1. It's a class full, but RIP version 2 is classless. It's a classless routing protocol. But point is how RIP will find the best path. All dynamic routing protocols will find the best path automatically. Agree? Like RIP protocol, OSPF, EHRP, BGP, all routing protocols will find the best path automatically, but in different parameters, different metric weights. So every protocol have own metric to find the best path. Then what is the metric of RIP protocol? Is in this topology from A to H, how many paths are available?
Paths.
3 paths. So traffic can go via which interface? Serial 0/0. Or traffic can go via 0/1. Or traffic can go via 0/2. Right? 3 paths. And each link hop count. Means traffic is generated. This data traffic, it will come to example 0/0. So 0/0 handover to which router? B. B handover to which router? H. H handover to LAN. Means from 0/0 to reach HLAN, how many hop count? Hop means handover packet. So 0/0 handout to B, B handout to H handout to LAN. What is the count? How many hops is done?
2.
2 hops. So hop count is 2 via 0/0. If traffic is going via 0/1, 0/1 handout to C, this is 1 hop. C handout to E, second hop. E handout to H, third hop. H handout to LAN, we reached the LAN. So total how many hops here?
3.
3 hops. The count is 3 hop count. Like via 0/2, D, F, G, H. Hop count is
4.
4. So then RIP will decide a shortest path is 0/0 is a best path. Because RIP protocol will find the best path based upon what?
Hop count.
Hop count.
Counts.
But I'm adding one more point here, remember guys. Hop count. Now tell me, RIP protocol will find the best path based on what?
Count only.
Hop count only. So it means 0/0, let's say via 0/0, overall link speed it is a 2 Mbps link. But in 0/1 have 80 Mbps link. 0/2 it is a 70 Mbps link. Now actually which path is the best path, tell me?
Second path.
Second path, 80 Mbps link. But RIP will say which path is the best path.
First
0
one.
plus 0.
Why?
Because it calculates only the hops.
Only the
speed.
hub. So it is not looking into how much bandwidth on the link. It is not considered bandwidth in our best path calculations actually. It will check only hop count. Then why we need to maintain the 80 Mbps link and 70 Mbps link unnecessarily? No need to maintain. Anyhow, it is not considering actually. Agree? So there's a major drawback, disadvantage of RIP protocol. RIP protocol will find the best path based on what? Hop count only. It does not consider any other parameters. Does not check how much traffic on the 0/0. Even it is more traffic, more load on the 0/0, RIP will say 0/0 is my best because of hop count is 2, less hop count. Even in 0/1 high bandwidth and less traffic, no, I will not choose that path because of more hops. But I have 2 hops here. I'll go via 2 hops. But bandwidth is 2 Mbps, more traffic. Still RIP says this is my best path. Getting my point?
Yes.
And one more drawback of RIP protocol is one, two, there are number of routers are connected. Have only one path, serial 0 path from source to destination. Like 0/0, serial 0 hand over to first hop. This is the first hop. This is router 2, 2 hops. Like between you have many hops considered. There are many hops are there. 3, 4, 5, 6. It is 15th hop. And it is a 16th hop. Now here data packet is generated. It will come to serial 0. Serial 0 hand out to which router?
R1
First
route.
hop. R1, first hop. Okay, here one hop. Like R1 hand over to?
R2.
R2 hand over to?
3.
R3, 4, 5, 6, 7. Finally,
16.
R15. R what R15 will do?
16.
R15 drops it. But what is the destination router?
16.
16th. So can we reach 16th hop? No, because maximum hop count RIP packet maximum can reach how many hops? 15 hops only. 16th is unreachable. Your RIP protocol can hand over maximum 15. So you want to use RIP protocol, you make sure in your topology, like a destination should be within 15 hops only. If your destination device in 16th or 17th or 18th hop cannot be reachable. But my destination router is here 16th. In 15th routers will say, so I'm dropping your traffic, cannot be reachable to 16. Maximum I reached out 15 hops. That's all. So metric of RIP is hop count. In the bracket, you remember this only, hop count only. And next point is maximum hop count is what? 15th. 16th is unreachable. So what do you say? Advantage or drawback?
Drawback.
Drawback of RIP. 16, 15 only reachable. 16 sound is not reachable now. Yeah. Okay. One more point about RIP protocol. It is R1 connected to R2, connected to R3, connected to R4, connected to R5. Is that topology? From serial 0, from serial 2, R1 LAN to R5 LAN. This is a scenario. Via S0, via S1, via S2. How many paths are available from R1 to R5?
3 paths.
3 paths. First path is 20 Mbps link. Second path is 60 Mbps link. It is 20 Mbps link. 3 paths via serial 0, serial 1, serial 2. Hop count via serial 0 hop count.
Only.
2.
2.
Only one.
Via S1,
2.
Two.
2.
via S2.
2.
Two.
So to reach to R1 to R5, there are 3 paths, but 3 paths are hop count is same. Then which is the best path?
Only
Uh,
60 Mbps is the
S1.
best path.
R1, R3, R5.
And that is why I clearly explained about RIP will find the best path based on what?
Only hop count.
Hop count.
Only hop count only. Then why you are going to be consider the 20 Mbps and 60 Mbps? No, it does not consider. Agree?
But here all are two hop counts, right?
All are 2 hop counts. Yes, that is what my question is. That is what. Like then, if all are 2 hops, then which is the best path? Like RIP will choose which one is the best.
All three.
All three.
Right. So in this case, when there is a equal hop count, when hop count is equal to reach one destination, then RIP protocol will use 3 links, all 3. We call it is load balancing mechanism. If you use any one, then all traffic will come to the link, more load on the link now. So why can't we use the 3 links? 3 are the best, 3 are equal, hop count is same. Then RIP protocol will send traffic via S0, S1 and S2 load balancing and faster communication. Is advantage actually of RIP protocol. RIP protocol supports for load balancing when for equal hop count. Yeah, can read this. RIP supports equal cost load balancing by default for 4, maximum 16 paths. Any doubts? Okay. Yes, please. Have any doubts? So for R1, R2, R3, I can have connected one backup link also here actually. Okay. Then all networks are directly connected networks. Say this is the topology. Regularly we are working the same topology, right? So head office is 10 dot network. Head office LAN is 10 dot 0 dot 0 dot 1. Says branch 1, 192.168.1 dot network. It is 2.1, which is branch 2. And WAN link serial interface 0/0/1. Serial 0/1. This is 0/0. Then tell me directly connected networks. I mean routing table in R1 router. Say this is your branch 1 routing table. Head office routing table. Branch 2 routing table. I made one backup link actually here. See from R1, how to reach to R2, how many paths? Via 0/0, you can reach out directly. What if link fails? So via 0/1 to R3, R3 to R2 and backup. So from each router, there are two backup links are available. So first let me write directly connected networks. What are the directly connected networks in R1? 192.168.1.0. via FE0/0. Next, 172.16.0.0.
Is
Let me write
01.
slash notation also, /24/16 via S0/0. Right? Yeah. Next, one more network. 172.18.00/16 via serial 0/1. Agree? These all are directly connected networks. In head office, in R2, 10.network 10.0.0.0/8. 16 is 0/1. 17 0/0. Correct?
Yes.
This 2 dot network. Serial 0/0 is 18. 17 is 0/1. Yeah. Okay. Now, in this topology, we need to implement RIP protocol. Let us implement RIP in this topology. RIP is dynamic routing protocol. So in R1, which is your branch 1 router, R1, R2, R3. In R1, if we configured RIP version 2, then R1 router will start sending automatic updates to neighbor. For R1, which router is the neighbor router?
Both
R2
R1.
and R3 board.
R2 and R3. So what R1 is doing is this complete routing table. It will send as the update to R2. It will send as the update to R3. Automatically updates. So to send these updates, RIP protocol will use one IP address that is fixed for RIP version 2. 224.0.0.9. So 224.0.0.9 is which class IP address? Is it class A or B or C?
Let's see.
Class
Class C.
No, it's a class
Class D actually.
D. Correct.
So 225
It's class D.
Class C, right?
224. 224 is class D, right?
Yeah. Up to 223 it is Class C.
Yes. Just a minute.
Okay, got it. Thank you.
Yeah, hello. So 224 is class D IP address. So class D are reserved for what purpose?
Multicast.
Class multicast. So what is multicast? Multicast means what? Then what is unicast? What is broadcast? It's all a type of communications. Unicast sending IP traffic from one to one. So source to destination is a unicast, one to one communication. Broadcast means one to all. Example, this is one network switch. In network switch, user 1, user 2, user 3, user 4, user 5, user 6, user 7, user 8, number of users are connected. Scenario is first user, the source device, is trying to communicate with fourth user, the destination. Data packet is generated. Now data traffic will come to switch. If switch is sending the data packet directly to which device? Fourth device. If switch is sending directly data packet to fourth device, then this type of communication we call what? Unicast. One-to-one communication. So sending IP traffic from source device to destination device, one-to-one communication is unicast. The same scenario, source is 1, destination is 4, and data packet is generated. What switch is doing is this data traffic it is sending to PC2, PC3, PC4, PC5. Like how many devices are connected in the switch? 9 or 10 or 20. It will send all devices in the network actually. One to all. We call it as broadcast. So unicast means sending one device to another device, one-to-one communication, source to destination. It is unicast. Broadcast is what? One to all devices. How many ports in the switch? 24. It will send to all 24 all. That's broadcast actually. But now we need to understand what is multicast. What is multicast? So multicast means one to a specific group actually. Let's in A router, I have configured, I'm running RIP version 2 protocol in A. In B router also I have running RIP version 2. In C I have configured RIP version 2. In E router I configured OSPF protocol. In H also OSPF protocol. In D I configured EAGRP protocol. Here also EAGRP. G also EAGRP protocol. But point is all routers are in same domain. One topology. All are connected. H is connected to B, like D is connected to A, correct? All are connected, but running with the different protocols. There is one 9-dot network, which is new network. It is added to A router. Actually, for A, which routers are neighbor routers?
C and D.
C and D. What about B? VDC, right? BCD.
Yes.
BCD are neighbors, directly connected, right? But now this new update router A will update, router A will send update only to B and C. Why?
It was configured with another version.
Like because B and C
Protocol is
belongs
different.
to same group of A. We are running the same protocol. So you are my neighbors. I don't know who is D. D is running with the EAGRP. Even it is my directly connected device, but I don't consider it is my neighbor because it is running with a different protocol, different algorithm. I don't know how it works because A is running with RIP. So if have any update, it will send only a specific group. Wherever RIP is running, that only will update action. So means there is a communication between ABC only. No communication with the D. D will not communicate because there is running the different protocol. So multicast means sending IP traffic from one to a specific group only. There is one new update in G router. It is 8 network. It is added here. It is a new update. Now what G will do? Router G will send this information to which router? Router G will send update to only F. Even H is directly connected, but H is running with a different protocol now, OSPF. So G will send update to F, F will send update to D, but D will not send update to A. So here DFG belongs to one group, E and H belongs to one group, ABC belongs to one group. If any update will send within a group only, that is we call multicast actually. So C and E will communicate? No, they are running the different protocol. B and H can communicate? No. So RIP also will send what? Multicast message. So it is sending update to R2 and R3. If R2 is running with OSPF, then what R2 will say? Whenever R1 will send update to R2, then what R2 will say? What is this update? I cannot understand. I'm dropping it because update coming from RIP. Update is from 224.0.0.9. What is 224.0.0.9? I don't know. RIP does not know. OSP will not understand it. Drop it action. Means we need to run same protocol. We need to configure same protocol in all routers. Configured RIP version 2 here. Configured RIP version 2 here. Now RIP version to understand, yes, 224.0.0.9, you are also RIP, I'm also RIP, we are belongs to same group. Let us start communication. Let us start exchange updates. Then all three routers will start exchanging routing information and update the routing table. Example, R1 is sending update to R2. What networks? 192.168 network. It is updating here. 192.168 is not available now, so it will update. 172.16 already available, so it can ignore it. 172.18 not available, it will add it. 192.168 2.0 update. 17 already available, ignore. 18 it is already learned from RIP R1 now, so it will ignore it actually. In R2 we can see 192.168.1.0, 192.168 2.0, 172 18.0.0. This networks. These networks are R. What about these networks are directly connected networks? Here, connected, RIP networks. Our networks will update 92168.2.0. Our networks 10.0.0. Our network 172.17.0.0. Correct. And here is C network, C network, C network. and RIP networks 192.168.1.0 or
22.16.0.0.
172.16.0.0. Right. Now R1, R2, R3 are maintaining up-to-date routing information, or did we miss any network? Please check and tell me. R1, 3 directly connected, 3 RIP. R2, 3 directly connected network, 3 RIP. Here also 3, 3. So every router maintains up-to-date routing information or not?
And do we have to cache this multi-cached address as well, or it will be like
Automatically carried actually. If you just
okay.
enable RIP, then 224 will come in the picture.
Okay.
Yes, all routers are maintained up to date or not.
Yes.
Yes. Okay. Even R1, R2, R3 maintain up to date routing information, but what RIP is doing is every router still it will exchange routing tables continuously for every 30 seconds. Same information, complete routing table, sending as update to R2, sending as update to R3. Continuously update, update, update. Why we need to send update? No need, already is maintain the same information. But we keep sending update for every 30 seconds. We call it is periodical updates. So periodically R1 is sending update to R2 router for every 30 seconds. Why? No need. When really update is required?
If a new router is added or
Any changes happens if link down or new router is added, if any link changes, right? Any changes happens, then need to update. But here, if there is no changes also, for every some time interval, 30 seconds, is complete routing table is sending is update. You practically understand how much bandwidth is utilizing, how much bandwidth is consuming actually, wastage of that. Agree?
yeah.
So RIP supports periodical updates. RIP sends periodic updates for every 30 seconds. Okay, so it's all about for RIP. Now I'll give the configuration part. You just implement RIP and understand. But our main target is OSPF protocol.
So the last point says maximum up to 16 parts and hop count maximum is 15. So we consider it from 0 to
Load
15.
balancing 16. No, load balancing is 16, but hop count is 15. Load balancing is different.
Okay.
Yeah. So I'm implementing RIP in first router. Just you can open the routing table, show IP route. You can get it 3 directly connected networks, config mode, router RIP, version 2. Network, you directly connect networks enough. Destination R2, R3 networks is not required. Only your R1 networks. You can get in routing table 1, 2, 3. So line by line you can advertise. 170.16.0.0. That's all. No subnet mask, nothing. So RIP, one more advantage is configuration is simple. Easily can configure RIP protocol. Network ID. That's all. Network ID. Network 192.168.1.0. Done. This is R1 configuration. In R2, show IP route. 3 directly connected networks. Router RIP version 2. Network 10.0.0.0. Next 172.16.0.0. Network 172.17.0.0. That's all. R2 is done. Just open routing table, whatever networks in routing table, and line by line I have configured here. Correct? In R3. Anyone help me? R3 configuration commands. Enable, show IP route. Then you can see routing tables, directly connected networks. And go to config terminal. Yeah. Router, RIP, version 2. Okay. 172.17.0.0. 172.18.00. 192.168.2.0. That's all. Directly connect networks. Done. Now in R1, back to privilege mode, if we check show IP route, you can see our IP networks.
So we don't need to define any interface.
No need. Very simple to configuration. That's that network space network. That's all. Okay. All right. So practice on this RIP protocol and 3 routers. And tomorrow I'll continue with some more protocol. Another protocol which is OSPF protocol.
So from exam perspective, do we get
We'll get only
questions
for
on
OSPF.
we won't get on RIP.
Yeah.
Said Balu, as you said earlier in the first class, that the first week what you taught is a main crucial kind of entire subject. If we keep more close to that particular subject, we'll be able to clear the certification.
First week is it is a fundamentals, right?
Yeah.
Even from the first week sessions, you'll get almost 10 to 20% questions. 15 to 20% questions will get from first week sessions actually. IPv4 and OSI from these two topics, OSI and IPv4 addressing. Yesterday we discussed about subnetting also comes under IPv4. So from these IPv4 subnetting and OSI, from these almost you'll get 15 to 20% questions. You no need to worry about your certifications. I'll help you on that. Okay, you just focus on the content and regular syllabus.
Balu, I need to follow up yesterday's class. I missed yesterday's class because due to emergency, I have to leave.
Yeah, you just go to the recorded video. If you have any doubts, let me know. I'll try to help you out on that.
Thank you. Thank you, Balu.
Thank you, guys. I'll continue tomorrow. Have a good day.
Bye.